100 pinball machines. And he's that type of guy that has the perverse pleasure of wanting to fix games more than actually play games. He spent, he spent 30 years as service tech in CoinOp. So I'd like to introduce John with 5 cheap tricks to fine-tune your solid-state game. Thank you, John.
Thanks, Ron. And I want to welcome everyone to the Golden State Pinball Festival. Thank you for attending today. I wanted to get started with our presentation of 5 cheap tricks to fine-tune your solid-state pinball. So the first thing that I'd like to share with you that works really well for me is, and I should probably also say my collection is predominantly 77 to 85 Bally. These are games that the 6800 microprocessor, very similar to Stern games, same era. But what I'm going over with today will encompass many different brands, and you'll see the transfers. But the pictures that you're going to see and what we're going to talk about is because I'm the Bally guy, so that's what you're going to see a lot of on the screen today. But what I've added to a lot of my games, in fact, every game that I add to my collection, is a 2.2 microfarad polyester film capacitor across the legs of the end of stroke switch. And what that does is it de-arcs the switch. And in fact, in System 11 Williams games added that from the factory. And this will work on any flipper mech that has DC voltage, meaning that the old electromechanicals had AC. The capacitor will not work in this situation. So if it's a solid state pinball that has DC coils in it, then this method works well. So what we're going to do is you disassemble let me back up a little bit more, is what we're going to do is we're going to rebuild this end of stroke switch. I looked online, and right now a replacement end of stroke switch for a Bally pinball will set you back around $7.50. And it's going to continue to wear out. It's going to arc and spark like the ones that you see here. By adding the capacitor, it de-bounces, it de-arcs the end of stroke, and therefore you don't need much material left on that switch. You can file it down with a nice fine file and get the surfaces together. So we're going to move on here. What I use is just a normal old stainless steel brush and a nice fine file to file that down and to clean up the carbon and get that off there, and then take the file and go ahead and file that flat. Now, again, remember, we're removing a lot of material from this switch, but because it's being debounced and it's not going to arc again, it doesn't need much material, and it never will, again. So we're saving that switch for reuse in our flipper mech. So what you do then, and this is where you can see where I've taken the capacitor here, and I've put it across the lugs. And this, I know you can't see it here in the photo very well, but that is, I have a Centaur that I did this on about 25 years ago. And that is what 20 to 25 years of use with the capacitor installed will do. Will go literally forever with no issues whatsoever. And so again, in the theme of being cheap, we were able to reuse our parts. Instead of paying $7.50 for a switch, or for an end of stroke switch, we were able to buy a capacitor for $2.50. So just one of those things that has always worked well for me and has a long-lasting benefit. Any questions? Okay, moving on. The best scraper money can buy for free. I don't know if you guys have these lying around. I added this in. It's kind of a quick and dirty thing. But old cracked pop bumper biscuits, you can see you take the stem, the activator off of it, you just slice it off, and then you come up with a nice round sliding scraper. It's great for taking off decals off of aprons. Anything on your play field that you would use your thumbnail for, this scraper is going to take it off. It's going to protect the paint. It's not going to abrade the surface. It's not going to leave scratches behind in like a ball apron or something like that. So just a little quick trip. You probably have a few of these old biscuits laying around, and you either throw them away or whatever. Repurpose them, and they're really great for doing that. And also, like when you're taking Mylar off of a play field, it has like that goo and residue on it. Again, that scraper can help pile it all up so you can kind of get it together and pull it off. Moving on to number 3, this is kind of a near and dear thing to my heart is reusing header pins on a circuit board. First of all, people are probably going to say, why would I want to do that? Second of all is I'm cheap, but I also want it to be done right. And if you were in the previous seminar when you heard Rob Anthony talk about his devotion to his soldering iron and brands of the like, I think they're like religion. Everybody is partial to their favorite brand of soldering and desoldering. I personally purchased a Pace desoldering iron probably 10, 15, 20 years ago on eBay for like $100, and I still use it to this day. The tips are cheap, the filters are cheap, and they have great suction. I mean, the great thing about a Pace is that the waste solder that you're vacuuming off goes into a glass chamber. You can clean that glass chamber out and reuse it again and again and again. And what Rob was saying earlier is that, when you're wiggling the components and some of the things, you sometimes will make that tip get wider and wider and wider. I set those aside as they get bigger and bigger, sometimes using like a acetylene torch tip cleaner that has a little bit of an abrasive in there, and you ramrod it through there a few more times, and then they get big enough so you can unsolder the larger pins. So once it's used up its life, desoldering the small pins, we can reuse it again on that same tip to take the larger pins out. So in this particular example, this is a Bally CPU header pin where the pins are, you can see right here, that right in this line right here, and I'm sorry I'm shaking, is where the actual mating surface of the plug is mating with the pin. But believe it or not, it only does it on one side. And so the other side is unused. So what we're going to do is you unsolder that header pin from the board and go ahead and flip it over, and we're going to mirror image that so that you take a stainless steel brush, again, and clean up those pins and reinstall them. And how you do that is you take a vise, and I'm going to, if anybody's interested after the conclusion of the demonstration, I actually have some of my stuff set up in the back here so we can, I knew I wasn't going to be able to do it with the camera like Rob did, so I will actually provide a hands-on demonstration at the end of my presentation to show you how we can go about reusing these pins. You go ahead, as you can see here, as they came out of the circuit board, I take a small hammer and I tap them. The side that has the plug on it gets pushed down first because, as you can see, there's little itty-bitty tidbits of solder that are still residual from where you had desoldered it from the board. So this is the both front and back side. Again, now we're going to take that same wire brush and clean up the pins, and you can see they're starting to get a nice shine to them again, and you tap again, reversing it, so now you've cleaned the little bits of solder off with the wire brush. So now you can tap it the opposite way and get them through so that they get the actual part where the longest part where the actual mating surface is. So now you've pushed that through the header pin and start cleaning on that side of it. Then you have the entire pin, because you've moved it to both ends of the pin and you've cleaned it with the brush, the entire pin is now clean. So what you're going to do next is take tap the pins to the midpoint, and then also take out wherever the key pin was and reverse it. So this is pin 4. We're going to take this pin and put it over here. And that way we're reversing how the pins lay out on the board. And you take an old plug, and I don't recommend that you use, when you do that, set it aside specifically for this because there's junk, there's stuff. You don't want to contaminate a new plug or something you're going to use in a pinball machine. Just use this and kind of earmark it for this process. And so you'll take and move the pins into the midpoint, install the header on it, and I have a vise, like just a normal bench vise, and then you can slowly crank that shut, and then you're pushing all those header pins into the plug, and it sets the depth perfectly. Now, on some of the Stern boards, some of the early Bally boards, you'll see that the pins have actually either started to get cold solder joints or they're coming out, and that pin is not even level. Like there's a few of them that are really nice and flush in there, and the others there's hardly anything left, no material left for you to solder to. So this takes care of that. It sets all the pins at the right depth. Any questions? Okay. Here's another little trick that I come up with over the years, is to use an inductive amplifier, which is basically used in cable identification in buildings, things like you're going to try to, you have a bundle of 50 or 100 telephone wires in a bundle, and you want to know where the actual wires are on the other end. You can use this as an inductive tone generator, and this is the inductive amplifier. So what we hope to do with this is this is a Bally like Mystic soundboard here. The capacitors usually will start to dry out and create an audio open for this circuit. And that generally happens most predominantly on any area where there's an electrolytic capacitor versus the non-electric like this one, electrolytic like this one here. So anytime you see the plus sign on that electrolytic, you know that it's a tin can type capacitor, and those are the ones that are drying out over age and over time, and just they're the ones that usually will open up and break up the audio path. So what we're going to do is you take and probe where on the circuit, and you start to trace back where you lost the audio. And if you get to, for instance, like here's TP6 on a Bally Mystic soundboard, that is directly output of the synthesizer AY3-8910 chip. You can actually you can hear the audio tone coming through this, and you can find out where it stops. And that gives you a good idea of what component has failed. Also, I can't tell you how many soundboards I've had to repair that the volume pot had failed. Bally and Stern, again, cost savings measures. They used an open frame kind of potentiometer that would get kind of crackly when you turn it with your hand and things like that. I would recommend that you buy a sealed potentiometer so that it cannot become contaminated, and that, again, you'll fix it once and it'll be done forever. But a lot of times these potentiometers will fail that way, and so you'll be able to identify that by seeing a stop in the audio path with the inductive amplifier. And again, I do have a head set up in the back. If we'd like to have a demonstration at the end, I'd be happy to do that for you. Any questions?
I think that if I understand it correctly, you have to put the game into one of the test modes where it is actually generating an audio signal?
Correct. Like on a Bally game, it would be self-test 4. Any others? Oh.
And an alternative, if you have something that can create the signal, and say you put it at TP6, then you could follow it from there, and you could do it outside the game.
Right. If you had like an iPod or something like that, you can also create a little bit of audio, and then you can test all the different stages of the amplifier circuit. Okay. Move along here. Lamp sockets. Ugh. How to permanently fix those bayonet sockets so the lamp does not flicker. You're going to go out tonight, you're going to play games out on the thing, and you're going to go like John just talked about this, and it becomes annoying to see these lamps go dim, bright, dim, bright, dim, bright. The biggest problem that's caused by is right here, this is a mechanical fitting where the frame is pressed into the cup. And over time and over vibration, that mechanical crimping has become loose. And so that creates resistance in areas where, again, we don't have a 0 ohm or a full electrical connection between there. The other part it happens is right here, where, again, it has to go from the actual wire on the lug here through this little copper brass fitting into the post, that touches the center part of the bayonet socket. And so we're going to overcome that problem by minimizing the areas where you could have unwanted resistance in the electrical path. So the first thing we're going to do is we're going to remove the wire from the tab. And again, using our trusty file, we're going to go ahead and abrade this area right here of the tab of the light socket and tin it up using a a lot of heat, and like what Rob was talking about earlier, like a soldering gun, or how much wattage do you want, the more the better. We're not dealing with electronics here, we're dealing with an actual like physical repair using the solder to create a bond. So we're going to tin that up and put a little drop of solder on it there, and then we're going to mount that wire directly to there, so we're eliminating the area right here where we could have a potential for resistance. The next thing we're going to do is take the bulb socket and lay it horizontal. Again, using the same file, is we're going to take and abrade the area between the cup and the frame. This is where you can feel them. A lot of times you can twist them with your fingers. If you can twist them, there's resistance. It's just a guarantee. Again, we're going to take and abrade that up and get some fresh metal and make it easy for the solder to adhere to that area right there. And then go ahead and tin that up. And then you have eliminated the majority of areas where the resistance is. And then you only have a few more to go. That's it, just a few hundred more and you're done. Honestly, for me to do a play field, I also, you can use a hand file or a Dremel tool. Anything that can abrade that works well. I'm thinking 4 hours or so to do a typical early solid state Bally to do all the sockets. And thank you very much. I appreciate your time and hope that I've been able to share a few things with you. I do have some show notes from the seminar. If you care to drop me an email, I'd be more than happy to send you my show notes that kind of outline what we've done here today. Any other questions from the audience? All right, if this is kind of the end of the video portion of the presentation, you are more than welcome to join me in the rear of the exhibit hall, and we will do the actual hands-on. And thank you very much for your time.